Okay, so we're gonna move on now. We're gonna actually write out what that cookbook recipe list is here. So I'm gonna grab and do blue. So we're gonna say, all right, so SOHCAHTOA cookbook recipe. So recall that the very first step that we're gonna have to do here is we are going to have to label the angle we know or want to know as theta, but not allowed to use the right angle. And that's really important. Okay, so what I mean there is, of course, when we go to do this, we're going to be either looking for an angle or be given an angle. And if we don't have those scenarios, then we can't really go ahead. So if we have an angle that we know, we're going to put our theta there, again, assuming it's not our right angle, or if an angle we're looking for, we're going to put our theta there. And that's got to be the first step because it informs our second step. And so I'm going to go color-wise here, so I have no idea. I'm going to use this color. And then our second step then is going to be, we are going to label each side with H, O, or A. Okay, and we're going to do that recalling, of course, that H is short for hypotenuse, and O is short for opposite, and A is short for adjacent. And we use the theta to dictate where our O and our A go. H is always going to be easy. H is always going to go in the hypotenuse. So that's located opposite the right angle. So I'm going to put that in over here. So hypotenuse is always going to be opposite the right angle. And then opposite, well, opposite's an interesting one. So opposite is opposite from our theta. And adjacent, really adjacent ends up being the leftover side, or it's the side that is attached to where you put your theta that's not the hypotenuse. So this will become a lot more apparent when we do more of those examples. So first step, label the angle we know or want to know is theta. Step 2, label each side with HO or theta. Our third step, let's change to whatever color this is. Those two colors look the same to me. Hopefully you can tell them apart. So we're going to write out HOA theta. And what we're going to do then is we're going to write them out and then fill them in with our known values. Okay, and again, when we do an example, this will become really obvious. So I'm going to write out HO theta. If I know what the hypotenuse is, I'm going to say, oh, the hypotenuse is whatever the known value is. If I know the opposite, I'm going to fill in I know what the opposite is. And same goes with adjacent, and same goes with theta. Now, theta will always either be populated with an actual angle, so it might be 62 degrees, or it will have a variable there that we're looking for. This will never be allowed to be empty, whereas H, O, or A, there will, the potential for one of those to not have either a variable filled in or a value filled in. Okay, so we've got now our populated HOA theta. Our fourth step is going to be, I have no idea. Fourth step is going to be, what we're going to need to do now is decide which primary trig ratio to use. Okay, and we're going to do that by using SOHCAHTOA. I need to move you out of the way. So So we're going to write out our stop that. SOHCAHTOA. And depending on what was populated in step 3, it's going to dictate which of our ratios we're going to use. If we have O and H, we're going to use sine. If we have A and H, we're going to use cos. And if we have O and A, we are going to use tan. Okay, so when we have that, we are then going to, so we're going to use that to decide. So let's say arbitrarily that we say, oh, we're going to use tan. The next step that we're going to do here is step 5 is we are going to fill in the values. Okay, so we are going to then, it's always going to be of the form. So fill in the values of the form, and it's, that's terrible. It's going to always be sine, cos, or tan, depending on which one of these we've chosen. Standard of always theta is equal to the first letter over the second letter. Okay. So what we're going to have then is, this is going to be my first letter. This is going to be my first letter. This is going to be my first letter. And this is second. This is second. And this is second. And so if we've established, so in this, pseudo example, we've said, oh, I'm going to use tan. So what it would look like for this particular example is we would say, okay, it's going to be tan of theta is going to be equal to first letter, which is O, over second letter, which is A. Okay, so this is what it would be for this particular example. So we've got 5 steps there, and all we've done is constructed what we need to solve. But that's in really, it's more than half the battle getting to that phase right there. So then what we're going to do is we're going to actually start to do the actual math that's associated with this. Oh my goodness, there's so many colors. Is that a color? I hope so. So then in step 6, what we're going to do is we are going to solve. Now, there are 3 different cases that we can end up solving for. So I'm going to separate these into cases. So case 1, case 2, and then way over here, we're going to have case 3. And I'm going to simply write out examples and talk about how we would solve them depending on the cases. So it's always going to look like this. It's always going to be sine, cos, or tan of an angle equals a value over a value. Now, the variable could appear in one of 3 places. It could appear here, it could appear here, or it could appear here. So those are the 3 different cases. So case 1, we'll start with the easy one. So imagine that we had the tan of 70 degrees is equal to x over 5. So this is where the variable appears in the numerator, and we have values for the angle and we have value for the denominator. Case 2 would be, let's say, imagine we had the sine of 50 degrees equals 7 over x. Now what we're looking for is in the denominator, and that's a bit more of a challenge. It's not wildly challenging, but it certainly is a bit more involved than the case that's over here. And then case 3 is, imagine that we had the cosine of x equals 15 over 24. And in that case, what we're looking for is the variable happens to be inside the angle. So these are the 3 different scenarios that we can end up with after we've walked through our cookbook. And solving these is all done a little bit differently on a case-by-case basis. So if we take this case as an example, when we're looking for something that's in the numerator, it's the simplest case. Okay, I'm just going to grab this and move it into a little bit easier to access area. Very good. when we have what we're looking for is in the numerator, well, we want to solve for x, and right now x is simply being divided by 5. So I'm going to multiply both sides by 5. Those are going to go away, and we have that x is equal to 5 times the tan of 70 degrees. And we could just type that into our calculator and get a result. We'll do that in a minute, but there it is, easy peasy. Here's the case where what we're looking for is in the denominator, and it's definitely more of a challenge. It's not overwhelmingly challenging, but we can, it's a bit of a challenge. So I don't want to just multiply or divide by 7 or anything like that, but what I'm looking for is in the denominator. So I don't want it to be in the denominator. So what I'm going to do, I'm going to show you what the actual math is, and then I'm going to show you a shortcut that I'm happy for you to use. I'm going to multiply both sides by x because I don't want x there. Okay, so I'm going to multiply both sides by x. Those go away, and now we're going to have that x times the sine of 50 is equal to 7. Well, that's a little bit better, but x is being multiplied by the sine of 50, so I'm going to divide both sides by the sine of 50, divide by the sine of 50. Those are going to go away, and we now have that x is equal to 7 over the sine of 50 degrees. Okay, so what I have there is, again, that's something that can just be typed directly into my calculator. I assess that in my calculator and have x equals, and then whatever the value is. And again, we'll come back to that in a minute. So that's that scenario. I'm now going to move on and look at how we would solve for case 3. Okay, so I'm just going to make myself a little bit more room here. Go along over here. So case 3 is a bit more of a challenge, but what we have is the variable is inside of the argument for cosine. So right now, this cosine is acting on the x. Well, if we think about opposite operations, we have to figure out what cosine is happening to x. So let's think about some other operations. So imagine I had x squared equals 8. Right now, x is being squared. To get rid of squaring, we square root. So that's how we'd get x by itself. If we had x was equal to 25, we'd say, 6 is multiplying x. To undo multiplication by 6, we divide by 6. Well, cosine similar. Cosine is an operation that's happening to x. So if I want to undo cosine, I'm going to have to do cos inverse. So again, I'm going to show you the kind of the long way around. So it would be the cos inverse of the cosine of x. But if I cos inverse on this side, I also have to cos inverse on this side over here. So we'll do that, and we're going to have then the cos inverse of 15 over 24. Well, these two are opposite operations to each other, so they just undo what they each do. So I'm left with x equals, and then I'm going to have to type in the cos inverse of 15 over 24. Okay, so those are the 3 cases. Okay, so what I'm going to do is I'm going to stop so you can take a break, and then we're going to work through all sorts of examples of this to get proficient at it. Okay, thank you.